Hello everyone. So I would like to show you how do we solve these equations. If you refer to your statistical book, exercise 7.1, page 297. So in this case we are given a finite line current which moving or start flowing from 1 to the origins. So that's our line current positions or directions, and we are going to find the H field that appear at this point of interest at 0, 0, 5. So that's going to be our point of interest, and this is our line current. So previously we derived already the H equation for the finite line current, so we can just simply use back that equation because this line current is straight line, so we can use again that equation. So it's shown here, the H is equal to the phi I 4 pi r sine alpha 2 plus sine alpha 1. So now our task is to find the value of alpha 1, alpha 2, the R as well, and the I is given already, which is 10 ampere. So now guys, the R actually here, the R here is a distance that normal or perpendicular from line current, this line current, to the point of interest. So the R here is something that must be normal or perpendicularly. So you can see from here, this is the line that joining from point of interest to the line current in perpendicular, shown here. So you can simply say that this R actually is this value 5. So become 5 because the R is distance that measured perpendicularly from line current to the point of interest. So now we have to find the alpha 1 and alpha 2. So this one can be found after we connecting the lower limit and the upper limit of line current to the point of interest. So that's the first step need to be done first. So join them, because this is your A, your initial limit, and your B, your final limit. So joining the A and point of interest is shown here. You will see that that's going to be our line that joining from point of interest and the initial point of line current. So we can see that this range of alpha referring to your alpha number 1. Okay, and how about the alpha number 2, guys? If you see from here, the alpha 2 is 0, right? The alpha 2. Why? Because the line that joining from point of interest, the B, is exactly on the line that perpendicularly connecting from line to the point of interest. So they are sharing the same positions, they are sharing the same locations, so the alpha 2 becomes 0 for this case. So here we don't have the value. So now we can find the sine alpha 1 by using theorem Pythagoras, this length over this length. Now we know that, guys, this length is 1 given here, and then this length from this one to here is 1 as well. So back we can simplify this total length become square root 2. Agree? So now we have here square root 2 and here, so we have 5, the length of the line. So again, using the same theorem Pythagoras, we can find this length that joining from A to the point of interest as given here, 27 square root, because 5 squared plus 2 square root. Okay, that's the length of this line. So we can simply find the sine alpha 1 actually set 2 over 27. So guys, this part simply have here 2 over 27 square root, right? So now we have already this sine alpha 1, we have already the R is 5, we have also the I. So So now how do we convert this phi to the other component in Cartesian, let's say in S and Y? Because we need to do that to combine, let's say we are dealing with multiple finite line currents, so we need to combine them, so it's more accurate if we can convert this phi component to the S and Y or Z if any. So the best way to do that process is just to use this concept or method. The phi can be simply converted to the Cartesian component using the unit vector of line current cross unit vector of radius that perpendicularly or line that perpendicularly from line current to the point of interest. Okay, I repeat again. So this are actually unit vector that perpendicularly from the line current to this point of interest. So in that case, that's our line that perpendicularly. So the unit vector of the sign actually in Z, isn't it? So just simply substitute this term becomes Z, because this is a unit vector of what? Of this vector. Vector that perpendicularly from line current to the point of interest. So that's your vector that perpendicularly. So you need to find the unit vector, so just take the Z, because you can see here and show you. Let's say I want to take this vector, become how long? 5Z, isn't it? Vector from here to here, 5Z, isn't it? So over each line, how long the line? 5. So you have here finally Z component. Okay, again here guys, for this case, a unit vector as well for the line current, this one. So the first step is just finding the vector of this line current over its magnitude. So if you see closely, you can get this vector by combining this vector plus this vector, isn't it? So the vector for the line current actually is given as a negative x component minus y component, the vector only, and now I want to find the unit vector, so just divide by the magnitude, then become unit vector of this vector. So that's how we convert or we transform from the phi to the Cartesian component in S and Y. So now let's do the operation of cross product between these components. So the phi have here negative x, negative y over 2. The whole term is your unit vector of L, line current, cross Z. So again, we are dealing with cross product between unit vector. So now let's do the simple approach. We have here a Z component, here we have X component, here is Y component. If you do X cross Y, you're going to have Z. If you do cross Y cross Z, you're going to have X. And again, for the Z cross X, you are going to have a Y. So now in this case, we have X cross Z. The X cross Z going to be a negative Y, because against the directions. So now you can see from here, the X cross Z, here you're going to have negative Y component. And now again, second time, I want to do for the Y cross Z, again Y cross Z, the output should be positive X. So here, Y cross Z, the output is X. Okay guys, so if you see back to this equation, negative and negative going to have positive Y, and negative also going to have negative X. So the phi conversion finally going to have here the X component, negative X component plus Y component over 2 epsilon to square root 2. So that's how we convert or transform from phi component to the S and Y component. So now you can substitute this conversion to these general equations. So finally you can have the H, can here negative X plus y component over square root of 2, then times with the I, which is 10, and also 4 pi and the r become 5. And then lastly, our sine alpha 1 is shown here, square root 2 over square root 27. So here 2 over 27. Alright, so that's how we solve this problem. Okay, you guys can try yourself and check your answer. Okay, thank you.